right, so today's homework is 3-4. It will be up on Digits by AO. So who can recap where we ended last week to kind of get our brains wrapped around what we're going to be doing today? So last week we kind of said that things were simple, not meaning that they were easy. Thomas?
Simple as in like just a like you get like simple interest.
Okay, how did we compute simple interest?
So you get a principal of $100 and there's like a little 2 extra percent, then you get more. You get $2. You get $2 if it's a 2% interest.
Yeah, so like we get the same interest every year. Today, we switch to compound interest.
I can see that this decision is hard for you. Choosing the right account is tough. Here's my advice. Take the 2% simple interest option. It's easy to compute, and that's a good rate. You'll always know exactly where you stand.
I don't know. That sounds good, I guess, but I don't know.
So it's very hard when you're talking to a banker, because some bankers are really trustworthy and like they're going to tell you what's best for you. Other bankers are out to make money. So when we look at this graph, we've got line 1 and line 2, and we had a graph similar to this last week. Notice that the graph is broken. How do I know the graph is broken? And what do I mean by a broken graph, Belle?
A line on the y-axis is like cracked, like it's not straight.
I call it like the lightning bolt. The y-axis is broken. It's got what looks like a lightning bolt. That shows that the bottom of my graph is 0, but then I jump all the way up to 100 because I don't care about the numbers between 0 and 100. Which of those do you think would be simple interest, and which do you think would be compound? So go ahead and notate on your paper right now. And we should be able to figure it out. Who thinks they know? Cassidy?
I think 100 is simple interest.
What do you mean, the blue or the red line up here?
Line 2.
Line 2, the red line, the straight line?
Yeah, and then line 1 is
Compound interest. Now here's what compound interest really does, and this is why I like to start with the graph. You make more money faster the longer the account has been open. So if you put money into an account with compound interest, then the first year you might make $2, but the next year you're going to make interest off the $102, not just interest off the initial principal. So where simple interest was interest made off principal, what do you think compound interest is calculated on? It's going to be interest based off the balance. Now, did you look ahead in your notes, or did you just figure that out? You just figured that out? So here we go. So we've got the graph that is similar to what we saw last week. We start with $100. That's our initial principal. That's how much we invest. After 0 years, well, we don't make any money. We just put the money in there. 0 years, we just started. After 1 year, I still make that 2% because my interest formula is still the P times the R times the T. And when the time is only 1 year, I've still only made 2%. Here's where it gets different. So actually, I'm going to capture this before I let us move on. So when I go from 1 year to 2 years, I'm now going to make interest off the entire $102. So am I going to make $2 or am I going to make more than that? More than that. If I'm making interest off a larger amount of money, I'm going to make more interest. So now, between years 1 and years 2, I made $2.04. Oriana? I have not, but thank you for the reminder. I will right after this. And then, so if we made, I want to see if anybody can guess this. If we made $2.04, and now computing, actually I think it might be on your paper. Did I already give it away? I did already give it away. Now computing off the $104.04. Now we make $2.08 with year 3. So every year we leave the money in there, we'll make more and more and more and more money than the previous year. Oriana?
Why is it 2.4?
So when you calculate, that's a good question. When you calculate the 2% of $102, so now we treat our principal like it was the 102. Notice how now our principal turns into, well, not really our principal, but our balance right here, it's the sum of everything that's in the account. So whereas last week we did just interest on what we started with, now we do interest based off everything we have. Does that make sense? So if we compare, I can pull up last week's notes to show the easy comparison.
By the way, how's your weekend doing, Dr. Who?
My weekend doing? Well, my weekend is over. So here's, I didn't want the board. I really want the PDF.
How was your weekend? Like,
It was fantastic. I played up on the roof, got my Christmas lights done. All right, so here was the graph.
Yeah. It's never
It's
too
the holiday
early. They already
season.
have like
Yes, it is.
Hey, all I cared was that the weather was nice. That doesn't mean I'm turning my light on. That means I put them up. I don't want to play on the roof when it's like 20 degrees outside. So, remember this from last week. If you have your last week's notes, it should be quick to reference. Every year, we made $2. So, every year it went up by the same amount. Now, the first year I made $2, but the second year I made $204 because this interest was based off $102. So the final step here, what you want to pay attention to, is just for 1 year of compound interest. And you need to, here on the line, write in balance. We already answered that question. Mr. Bunger answered that for us. This we should write in balance. So now my balance, to find this interest of 208, I compute from the balance of $104.04. Oriana, does that help?
Yeah.
Just a little easier to see the comparison. So, not Google Docs. I think I captured this, but we'll do it again just for good measure. So move on to our problem. Suppose we deposit $200. What can I immediately do with that $200? If I deposit $200, we know that's called my, Isaiah?
no, you're a principal.
It's my principal, which also would go where? Where would I put that on the table here?
I'll put in the balance.
The balance after 0 years. Because remember, if I've had my money in there for no time, I've made no money. So my balance at the end of 0 years, which is really at the beginning, is 200. Now my annual interest rate is 1%. Compounded annually once per year. What is the final balance of your account after 4 years? You gotta do this 1 year at a time. We've not yet dealt with the formula for doing this multiple years at a time. So, to calculate 1 year, your interest made equals the balance times the rate. So my balance is 200. My rate is 1%. Well, what's 1% of 200? $2, right? Because I just moved my decimal over 2 places. So if I make $2 that year, I now have $202. But now for year 2, my interest is now going to become 202 times the 0.01. Well, if I move my decimal 2 places over to do that 1%, my compound interest is now $2.02.
Yep.
So now for year 3, my interest will be 20. Well, now, sorry, I actually wrote this down wrong. This should be $204.02. So now this is computed off the 204.02. So if we move my decimal over, and again, we have to round it now. So my 1%, to see 1%, we can just move my decimal over 2 places. So now the interest earned, $2.04. Add that with the previous balance. We get $206.06. And my final step there, how much compound interest am I going to make, Orion? I take the balance from the end of the last year, do 1% of that. It'll be 2.06. So my final account balance here, $208.12. Now that may not seem like a lot, but you only started with $200. So what if you started with $15,000? Then the difference that you make because it's compound interest is way bigger. Cassidy?
For the compound interest, are you just adding 2 cents?
So for this case we are, because it was $200 and 1% of that gives me the 2. But, so let's set up another situation and try this out. Because it'll make more sense as we do another one that's got different numbers. So now, my interest rate is 3%. My principal is $500, and we want the balance after 2 years. So again, it would help to make a table with like years, interest, and balance. When I started my account, I made no interest. I had $500. After 1 year, well, to find the interest, I take my balance times my rate. So my balance is 500 times my rate of 0.03. So I can find 1% and then triple it. So 1% of 500 would just be 5. And then if I triple it, I get 15. So my interest earned in that first year is $15. So now my balance is $515. Now for after 2 years, my interest will be the balance from the end of the previous year. Karina?
I was just gonna add, this is on the back of the note, right?
I believe it's on there somewhere. Sorry, nobody left me a copy of the notes on my desk. I have to get my own.
What?
Can you give him a note?
Yeah, we're on the back now.
Oh, they are?
I went ahead and gave you the table. Yeah, guys, if you don't see an example, check the back. Because I try to put most of these on there. So then I calculate my interest based off the $515 times 0.03. Again, I could find 1%, which is going to be 5.15, and triple that will be $15.45. Oh no, my snowman. So now my total account balance after 2 years is $530.45.
That's a lot.
Does that make sense to us?
Dude, that's half of it. That's $1,000.
You only gained $3.
Yeah, but you didn't do anything. You just sat your money there. So pretty good deal.
It's a lot. It's a lot. More.
So
If you're poor, then yes.
what if I asked you to figure out the balance I'd have in this account after 30 years?
Holy whoa.
Are you going to do this 30 times?
No.
Well, you could.
No thanks.
Franny?
Didn't you find out what it was for 3 years and then multiply that by 10?
We could not actually. That's a good idea, but the problem is every year the interest rate doesn't, like the rate stays the same, but the interest amount that we make changes. So if you did if you just did that idea, the number that you'd find would be less than what you'd actually have. Because the compound interest every year you get more money and more money and more money and more money.
You multiply it by 60?
Isaiah?
Did you give it an exponent?
We can use exponential notation. So here is our compound interest formula to make your life easy peasy. Check out what we're saying here. My final balance, and I'm going to rewrite it as we talk about it. My final balance B. I'm still going to use my principal P, but then I'm going to do 1 plus the interest rate to the n number of years. And we don't use T now just because it gets complicated comparing to the simple interest formula. So why do you think we use this 1 plus the rate? This 1 plus the rate. What do you think that 1 is in there for? So what if my number of years is 1? Does the exponent of 1 change anything? No. So if I think about this after 1 year, there really is no exponent. Think about the principal times 1. That's the amount that you started with. Then think about your principal times the interest rate. That's the amount of interest that you earn. So your balance has to be what you started with, this first arrow here, and the amount of money that you made, the second arrow here. So that's why we use the 1 plus R, because that deals with the amount of money that I already had and the amount of money that I made. But we have to have this n number of years, because then that deals with the fact that I get more and more and more every year. The exponent lets that happen. Here we go, baby.
And do you know what this is, little baby Eddie? This is a certificate for a $1,000 money market account that will earn 5% interest compounded annually. Isn't that a wonderful gift your lovely Aunt Edna gave you? No, don't chew it. No, don't cry. And no, don't chew. And okay, who wants to hold little baby Eddie now?
So, figure this out on your own. Go ahead and try to give it a shot.
I did. I was a crybaby back then.
Try it on your paper. Try to not look up here. Resist the urge. Yes, most definitely.
Bam! I guess right.
Write out your work, so on your homework you're going to know what you were doing here. Remember, parentheses happens first, then exponents, then multiplication. So if I was you, for the first one here, I would type in 1.05, and then the caret, the one right here, on the TI-30, that is the exponent. So to the 10, I'd get that answer, then multiply by the 1,000. So just hit times and it just grabs that answer. we get that my final balance, and what's nice is I don't have to add this with anything. It spits out my balance. $1,628.89.
That's a lot.
So in 10 years, gravity works. In 10 years, you made $628.89 just by letting your money sit there. This, it says certificate of investment, but this is like when we talked about certificate of deposit, those CDs that you can get. That's the sort of situation. You put it away, you say, I'm not going to touch this for 10 years, and you get a better interest rate because 5% is pretty good. What about after 20 years? You'll notice the interest does not just double, it more than doubles. Because remember, you're constantly making more and more than you had before. Does anybody have this?
Yeah.
In your calculator, you type in 1.05 to the 20th. Get that answer, then multiply by 1,000.
How do you get to the 20? Why do we multiply?
You type in the caret for to the power, then just type in 20.
I got it.
So 1.05 caret 20. Yeah, you type in 1. Caret 20. Then do times 1,000. Just say times 1,000. Yeah.
I did it.
Help him out, Luke.
Okay.
So then we get 2,000.
2,650. It said my error. 0.297.
Yeah, we'll round to 30 cents.
I actually got that.
So you guys, look at this. Give me your eyes up here for a second. In the first 10 years, you only made $628.89. In the next 10 years, you made over $1,000. So the first 10 years, you only made about $630. The next 10 years, you made $1,000. So if we combine that, the first 20 years, you've made $1,653.30 for just leaving your money in the bank. Now, after 30 years, if you really left your money there that whole entire time, 1.05 to the 30th power times 1,000, we get $4,321.94.
How long does it take you to get $1 million?
A while. You'd probably be
You
dead.
were like 80.
It'd be like 1,000.
Yeah, it'd be a long time. Luke?
For the B times 20, it says 29.
20 to what?
Is
Where?
that a lot of money?
The blue one?
No, for the green one. It was 29 cents.
I know. I just rounded up. Because it was 0.297. So that would round us up.
Is that a lot of money?
So in 30 years, you made off interest $3,300 just off interest.
That's a lot, dude.
So you get your initial 1,000 back and another 3,300. Now, a lot is relative. A lot is a very vague term. A lot is like saying that's the best. Like, I went to Hound Dog's Pizza downtown this weekend, and that I think is the best pizza in Columbus. Actually,
Never
I've
heard
heard.
of it. Never heard of it.
Yeah, but like that's so. A lot is a relative term. Try the got it.
Who here knows what Andy
I want to see on your paper the formula set up. So everybody right now, just go ahead and write with me. B equals P times 1 plus R. Do not skip this step. I'm going to come around and look at your papers. To the power of n. Then plug in the values and do them. Hey guys, some of you are still writing really, really big. You need to let go of the whole like elementary school, I'm going to write as big as I can. You do not want to be taking up all the space. You want to be able to work vertically. different about this problem compared to the other problems we've been doing? Franny? We don't know the principal. Who messed up?
You.
I didn't mess up. I didn't write anything. So when you fill in your values, it should be $2,560 equal to the principal that we don't know times 1 plus 0.04 to the 12. Here's what you want to do in this situation. This is why I said leave some space so that you can actually work. Do this math. You can do 1 plus 0.04 is easy. It's 1.04 to the 12. Once we get that answer, rewrite everything we know, and that's not dollars, it's just a working amount. 1.6. Guys, check that you can do this in the calculator, because if you're doing it wrong, you want to figure that out now. Keep this number in your calculator. Do not clear it out, because it goes on longer than that. So what we now have after doing the 1.04 to the 12th power is that 1.601032219, that big long number. If that is multiplied by my variable, how do I get my variable by itself? Cassidy? We divide yeah.
Thing, and then divide that by itself. Then you would do 25.
Yeah, we do the same thing on both sides. Here's what you want to do in your calculator. To make your life easier, I want all eyes and ears on me, because otherwise you're going to get answers in digits that aren't quite right, and you're going to be annoyed. Here's what you want to do. When you get this number, leave it there. Don't hit clear or anything else. Then start typing the next problem. When you start typing the next thing, it will clear it up, but it's still saved in your calculator. That's why I tell you to use the TI-30 and not your iPhone. So if I type 2560 divided by, then hit second, the yellow button up here, or some of you guys it's just a lighter blue. Then the negative symbol grabs my previous answer. So right above it, it says ANS. When I do that division, you get about 1,598.96. That leaves the principal amount to be $1,598.96. But to the nearest $10, so my principal was really 1,598 would round up, so it's actually just going to be 1,600. So the nearest $10 rounds it up to the next 100. Oriana? I'll come back and help you with that one. Any other questions on the got it? I'm going to come back and help Oriana. Otherwise, you're going to move on and try the next example. Try the next example. Be careful when you set it up, because it is a little bit... Oh, hold on. I want to make sure that we cover this. I believe this is on the front. Yeah, I already gave you this formula. I need your attention real quick. Here's the biggest part that I would go back up and circle, highlight, star something. Right here where it says R equals, right in the middle of your page. R equals. The rate is computed by taking the annual interest rate divided by the number of periods per year. So if it's compounded quarterly, that means it happens 4 times a year. If it's compounded monthly, it happens 12 times a year. If it's compounded daily, it's 365 times a year. So when we start working with this, finding the correct R is the biggest mistake I see from kids. When they come to me and they're annoyed at their homework and they're getting wrong answers, they've not actually found out the correct R value. So, that's why N, we don't use T for time. N is our time because it's actually the number of interest periods, which is sometimes the same as the years, but not always. So here, I'm going to help you really quick, then I'm going to come back and help you, Oriana. My rate is 6%, but it's compounded every 4 months. If it's every 4 months, how many times will it happen in a year? 3, right? Because 4 months breaks the year into 3 parts. So to find my R, it's going to be my 0.06, my actual interest rate, divided by 3 times. And we'd get 0.02. Then compute the final balance of that problem. So I would not, do you have your own TI-3 like you're supposed to because it was on the supply list? Is it a TI-3? So you need a calculator that is like this one. So we use this one because it allows us to grab that second answer. So when we did the 1.04 to the 12, be careful because you don't really want to put in the capital sign because it makes it look like you did everything. So if you go so when I do that, it's big on. I then start typing 2,560 divided by second, which is what this Hey guys, if you're talking, you should be comparing your answers. And if you don't have an answer and I come around to your paper, you're going to the office. Because I'm tired of this behavior where it's like, oh, I'm just going to wait for the answer. No, you need to compute this on your own. I'm helping one of your peers. You're good. So, right. So, but then the problem is we need to use that number. So either we have to write it down or remember it, or in this calculator, I can now divide by that number, just hit second answer, and it pulls that number and puts it in for me. And that's how I get that answer. In this calculator, we can't, there's no way to pull that previous answer. So that's the problem. Yeah, it's weird. Just make sure that you're using the K correctly. Like, you can use this calculator, but then you just have to write everything out and then type it back in. So if you were using this calculator, you go 2560 divided by, and you type in what you have written, 1.60103, and then it'll still get the same answer approximately. Because we're going to round it, then you're okay. It's okay. This one just makes it easier. So, sweet. Use this for the rest of the class, and then set it back on my desk because I still need to label it so that it's in my supply. Anyone have questions? I'm going to show the solution. I want to know if anyone has questions before I show the solution. Here is what we would have done every 4 months. I goofed. I goofed and I apologize. So I was in a hurry to try to go help Oriana. When we compute that R, what's the total, and you're going to have to go back and erase some of your work, and I apologize, to find the total times number of interest periods per year. So wait, I think I did my R. But this N, actually I didn't goof anything up. My apologies. I'm freaking out because I thought I did. I did not set up the formula yet. Hopefully you realized that to find the N, if it's 3 times a year for 5 years, then my N is actually going to become 3 times a year for 5 years. How many total times is that? 15. So when we find our rate was correct. We had the right rate of 0.02. And remember, all this is going to be on Schoology, so if you need to go back and look through the solution. But my n, I take 3 times a year and multiply by 5, gets me 15. And then when I plug everything back in, this is what your formula should have looked like, what your equation. 1,000 times 1.02, or 1 plus 0.02, to the 15th power. We can do the 1.02 to the 15th, gives me approximately 1.346. Multiply by 1,000, and we get $1,346.
I was too. Instead of a 15, I put a 5.
I was off.
Yeah, because you need the total, not per year, but the total times it happens. So guys, again, like, these are the trap doors you're going to fall in. If you are getting an answer that's not correct, check with yourself, am I using the right rate? And am I using the right number of times? So let's do another one together. Let's set this up. We need to find our P, our R, and our N. So guys, it helps if on your paper you set this up to say, I can't just plug in, I need to actually find these values. I buy a bike on credit. This is exactly what we're starting to talk about with our Black Friday stuff, is cash versus credit. If you buy something on credit, you're going to pay back more than what you bought it for, because interest is going to happen unless you pay it back very quickly. So my rate here, might as well change colors to vary this a little bit. If it's compounded monthly, how many times is that per year? 12, right? And the annual rate is 30%. So to find my rate, I plug in that annual rate on top, divided by how many times per year, and my rate actually becomes...
0.025?
You say that with a question mark and it concerns
Oh, yeah,
me.
I did that. 0.025.
Yes. Don't ask it, tell it.
Because I was doing that on math.
And then my number of times per year, well, if it's 12 times per year, suppose you use credit card purchase of bicycle. If there are no additional late fees, how much would you owe after a year? 12 months. So that's 1 year. It's just 12 interest cycles. So now my balance actually comes out that 150 times the 1 plus 0.025 to the 12th. Again, we do the 1.025 to the 12th first. That gives me 1.34488. Another 8 if we want it. That then times 150. Guys, again, if you don't have a TI-30, please talk to your parents about this. This calculator is the best calculator out there until you step up to a graphing calculator. And these are way cheaper than the graphing calculators. And they're like indestructible. My friends, like, we joked in college about how indestructible they were. My friends threw one out of a 3rd-story window, hit the ground, and it still worked. Like, if you don't break the screen, they can last forever. The only way that I've ever messed up a calculator is it got wet, and electronics and water don't match. So if you keep the lid and you keep it nice, like, and keep it like in your pencil pouch or whatever, this calculator should last you forever. I'm still using that. So I messed up my calculator. I'm still using my wife's calculator from high school.
What?
That was 10 years ago.
Whoa.
The technology inside of a calculator doesn't change. Yeah.
So there were these 2 boys at my old school, and they were like, oh my gosh, they were crazy, and they just wasted everything. So once they got a calculator, it was their calculator, but they were like also trying to do that, and they started smashing it with a pencil.
Okay, well, yeah, that's a bad idea.
I know, but they kept on doing that over and over again for like 50 times for like a week, and it still worked.
Yeah,
Like,
I mean
the
they're
calculator itself
pretty.
worked, but the screen was
Like
shattered, so you couldn't
this,
see
the
anything.
front screen on this one's gone. I put tape over the solar panel so it doesn't fall out, but there's no batteries involved in these, and most of what fails in electronic is the batteries. They corrode, the acid leaks out, and it messes up everything. Because there is a battery in here. The solar power stores up into a battery, but it's like a really good battery. Please get one of these. Your iPhone is not a suitable replacement. You need one of
I bought
these.
mine today for the master. Keep on forgetting to
So we end up with a balance of $201.73. Round off to the nearest dollar. So approximately $202. Questions, comments, concerns? I want to show you an example of your practice problem so you're familiar with it and you watch out for the trap doors.